Good morning, guys. I say good morning. It is actually the morning. Apologies for not getting this review back quicker. I got caught up on a paper on Friday, so it's just taking me a little bit longer. Apologies for that. I didn't intend to take as long as I did. Right, so these review notes were purely about verification and calculating displacement for the materials and making sure that our material model matches exactly what we're looking for. It can be a huge issue if you put in a value. You don't know if that value is for right. It's the hardest thing is to understand exactly the amount of variables that are there, if you will. A lot of the time you're in a position where you're almost guessing. You've got to try and close it as much as possible. I mean, the amount of times you'll read a research paper where it says this was assumed, or this is not considered, and it's purely because people try to cancel out some of the biggest elements to just try and simplify what can be a ridiculously complicated system. And what people will do is gradually build it up. So this is like an initial step, if you will. If you consider it for simulation, this would be the first step. How do you know what you're using is a true recommendation? So rather than going through both sets of notes, what I thought I'd do for some giggles is I thought I would combine them. Now, I've never combined them before, so this is either going to work really well or very poorly. So we know from the notes that we had, it is a 2.5 wall thickness and it's a 25mm diameter, 100 newtons on the end, and 500 millimeters. So what I thought I would do is I'm going to actually use the linkers for the pipe, and let's have a look, see how it comes out. Again, I've never done this, so I'm going to drag and drop static structural, set some of my basic principles. We know that the stainless steel, or structural steel, sorry, is what was initially used. So what I'm going to do is go geometry. I'm going to right click. Let's go design model at geometry. Now, if you remember, everything in here is in millimeters, so let's set our units when we get in there. Apologies if you can hear backing out the outside. I didn't realise how loud that was going to be. Right, so we're into our modeler. Now, we know we've got a 500mm length, but first things first, let's get our units set. So I'm going to go to tools. Sorry, I'm going to go to units next to tools, and I'm going to go millimeter. So now we know from looking down here, that's our scale, confirms we're in millimeters. Happy days. What I'd like to do is, you see where Y and Z are. What I think I'm going to do is I'm going to model on the YZ plane. So it'll be over here. So what I'm going to do is I've selected onto YZ and I'm going to go line. And I'm going to right click and then go look at. So now we're in position. Track it to the center. You'll know when you're in the center because it seems to snap into the middle. And I'm just going to draw a length. I don't know how well this is going to work, but it's going to be fascinating to find out because we've got our verification calculation that we're going to aim for. So I'm going to go to dimensions. I'm going to general. And I'm going to left click once, left click again. Then we have a length of swine 500. So now we're into 500 millimeters. Fantastic. So I'm going to zoom to fit. My 500 millimeters length is in position. I'm going to generate. So now it's confirmed. Everything's in there, not a problem. So what I'm going to do is go to concept. Then go to lines from sketches. I'm going to confirm this to be my line and then apply. And if you remember, if I spin this up, it's actually, oh, generate. Sorry, I had to hit generate. But we see we've got the third plane line, which is third plane indicator, which is nice because now we're going X, Y, and Z, and that's just to confirm that everything's good. So the only thing I've not done yet is I've not added my cross section, and we know it's a 25mm diameter with a 2.5mm wall thickness, so we know RI is going to be 25/2. Oh, sorry, it's going to be 20/2, so 10, and RO will be 12.5. So let's go concept, cross section. We're going to go circular tube. Our RI is 10. Happy days. And I'm told that you can actually put it in by equation, so I'm just going to have a go. 25 over 2. No, not true. So we're going to go 12.5. So we're 12.5. Right, brilliant. So let's bring it back. If I just spin it back round a little bit again, it's 12.5 millimeters, and what we're going to do is attach it to this line. Right, so as you remember, I've got it in there, it's confirmed, it's happy, everything's yellow at the minute, but when I've expanded my bodies here, it's asking for line body. So what I'm going to do is, where it says cross section, it's saying, okay, fine, you've done that, but what is your cross section? So I'm going to say, that is my cross section. And what you see now, design model to edges, centroid, edges by right, and then if I click generate, all I get now, well, in fact, all I get now is nothing. So don't worry too much if you click it and go, what? It's not happened. You'll know for sure if you've got it right when you expand the body and go line. If it's yellow down here, you've not clicked apply. I know it sounds obvious, but it is one of them big things. So what I'm going to do is close that, and I'm going to go into, well, you can go into any of these because this is essentially where everything's sitting at the end. So I'm going to go sketch. It's because I've just been doing SolidWorks. I'm going to go setup, right click, edit. Brings in my solver, and with it bringing in the solver, great, happy days, and it's now going to set up my peripherals for the simulation. So let's just bring in edit. Any second now. There we go. It's the only one thing that irritates me, the amount of time it can bloody take to actually get anything made. Right, so first things first, let's have a look at the mesh. I'm just going to use the default, so update. Right. You'll notice these linker elements are still quite coarse. I can make them smaller, so I'll go medium, update. But even then, see how it's all still quite in its elements. Can go to a span angle, which talks about the distance across an actual circular point. I mean, with this refinement now, it should be fine, but we're going to run it and just see what happens. So I'm going to go to static structural, and I'm going to go support. Be interesting to see how this comes out, because like I said, I've never combined the two notes, but it'd be just interesting. So I'm going to go fix support. I'm going to go up here. Don't forget, up here we've got the different plane selection. So I'm going to, I can't remember what they call this. Oh, vertex or node point. So I'm going to click apply. If I've clicked on the edge, now be sure not to click on the wrong way around. This, bloody hell, this machine at the back of me, I don't know if you can hear this, it just keeps making bloody lots of noise. Anyway, so this is my fixed point. Do not click on the same point. If it comes back, it will be blue, and then all I ever listened to in my past experience is, God, ANSYS is whoa shit. It's not that at all. So what I'm going to do is go loads, and I'm going to go force, because we know from the notes, let me just swing them across so I remind you, we know from the notes that it's 100 newtons. These are the values that we're aiming for, so let's see what we get. Again, I've never done it like this, so it'd be interesting. If it comes out more accurate, I'm going to be gutted, because it means that the linker method is far more superior to what I've been essentially doing. I've selected on the endpoint, clicked apply, it's gone red, it's confirmed it's happy. I'm going to go down, go to component, and on here on Z, because I'm moving as opposed to the datum, I'm going to go minus 100 newtons, because that's my initial load, don't forget. And Because of this, because where we've done this, you're going to be blown away how quick this solves. I've even turned up, I mean, we could, for some shits and giggles, we could turn up the mesh, so it's super fine. It won't actually do much, but just for giggles. Right, so I'm going to go right click and, well, I can select static structural and solve. Give it a minute. 3, 2, 1. 3, 2, 1. There we go. Right, so we've now got it solved. It's now give us, in essence, I always do it this way because I like students to realise that if you forget to put a solution in there, don't worry, you don't have to solve it again. Because, don't get me wrong, this is taking seconds, but if you were doing a solve and it was taking days, you could come back and you could be screaming from the hilltops of how annoyed you are. So you don't have to do that. So my solution, I right click and I'm going to go insert. And don't forget, with this we're going to go, look at that, beam results. I'm going to go beam tool. See how the lightning bolts there? And I'm going to right click, evaluate. It's direct stress. Yeah, that went well. Let's go maximum combined stresses. Oh my god. So look at my maximum combined stress. Look at the top one. We've got 5.5. Maximum stress 5.5. Ah, shit, this is actually better. Oh, that's not good. Anyway, the issue is if I look back here, the way that this has been solved, all it can actually do is it can identify points and where the maximum stress is. It cannot give me an overall. So the meshing procedure for that I'm using, as much as it has given me that verification value nicely, if that was the end of what I was doing, then this would be fine. But if this wasn't the end and I was making a tube for, I don't know, let's say mountain bike, like the Marin example, I'd need to know the maximum points of concentration, so perhaps I could improve, I could change the design to actually make it better. So this, yeah, it gives me that, it's giving me a nice result, but it's not the best. So let's see if we can pull some, let's have a look, beam tool, deformation, total deformation. What's this going to give me? I think this is going to be out. Oh my god. Right, so we are on 185 and 164. Come back here. Look at that. Without any refinement, without any messing about, it's actually giving me a better result. Damn, 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 damn. So again, if this is my end target, if this is all I'm looking to do, if I'm just looking to verify this material, I suppose this would be just as good. A verification for a material model is actually, dare I say it, it's better than my notes. Damn it. Who'd have thought? Anyway, so that is an amalgamation of the notes from this verification model. So if I come down, you remember this. Let me come down, come down, come down. It's a verification from, wow, I even done a verification on APDL. Didn't realise that was there. Ha! So it's a verification model on this, and yeah, it's done a pretty good job. I'm actually quite impressed. But that's just a review really of what we were doing and why we were doing it. I thought I'd combine the two because you've got the notes to support for the different truss and for the pipe verification, but I thought if I combine the two as an example, something that we haven't done but it's a little bit extra, because this just shows you a way of simplifying the process dead quick when all I had to do was just simply draw a line. So that's me. If there is any questions, please do not think twice. Come and see me, let's have a chat, and I can try and show you further understanding of what it is that we're doing. Or if there's anything burning in your mind of that, I don't like this or I'd like to change that, let me know, and I'll see what I can do. Okay, guys, if I don't hear from any of you, I will see you this coming Tuesday. Sorry, I will see you this coming Wednesday and Thursday.